Audio Jungle.
Good day, everyone. This is Group 8 from 11 Diligence. Today, we are going to show you the properties of liquids. There are 6 physical properties of liquids: surface tension, capillary action, boiling point, vapor pressure, molar heat of vaporization, and viscosity. The first is surface tension. Surface tension is a property that causes the liquid surface to behave like a stretched, elastic membrane, resulting in the formation of nearly spherical shapes in small liquid droplets and soap bubbles, and enabling certain insects to stand on the surface of the water. The next is capillary action. Capillary action, also known as capillarity, refers to the ability of the liquid to rise in narrow tubes or be drawn into small openings. It occurs due to the attractive forces between liquid and solid materials at the molecular level. Cohesion refers to the attractive forces between molecules of the same substance that allow them to stick together. Adhesion, on the other hand, refers to the attractive forces between molecules of different substances, causing them to stick or adhere to each other.
In this experiment, I will demonstrate to you how capillary action works. The materials you will need for this experiment are tissue, tape, stick, or any kind of pencil, a cup, and a colored liquid. In this experiment, I used acetone. What you're going to do is, you should take tape off and put it in the tissue. After that, stick it to the pen so that you will be able to hang it there. After that, you're gonna hang it right there. But first, let me put the liquid first. Like this. After this, the last step you're going to do is you're just gonna put it right here. And watch closely. As you can see, the liquid rises up into the tissue, and that is how capillary action works.
The next is boiling point. The boiling point of a liquid is the specific temperature at which its vapor pressure matches the external pressure, causing the liquid to undergo a phase change and convert into gas.
Vapor pressure is the pressure between a liquid and its vapor at a certain temperature. Volatile substances easily turn vapor because they have weak forces holding them together. Examples of volatile liquid are alcohol, gasoline. These substances can burn easily because they mix quickly with oxygen.
In this experiment, we will need a glass jar, plastic cover, an elastic band, ice cubes, and a cup of water. And of course, we will need a source of heat to produce vapor pressure. Fill the jar with water and then cover with a plastic bag and secure with an elastic band. Next is to make holes on the plastic cover. We will now start boiling the water. Wait until the water hits its boiling point. After that, take it out of the pot and put the lid on securely. Next step is to put the jar upside down and put the ice on top of the jar. As you can see, the water is boiling. To boil the water, we need to increase the temperature or lower the pressure of the water. In the scenario, ice cools the bottle rapidly, making the pressure drop.
Next is molar heat of vaporization. Vapor pressure and intermolecular forces affect the molar heat of vaporization and boiling point of liquid. Molar heat of vaporization is the energy needed to vaporize a liquid, and enthalpy represents heat content at a standard condition. Viscosity is how thick or thin a liquid is, and it affects how fast it flows. The thicker the liquid, the slower it flows. Furthermore, viscosity and temperature are inversely proportional to each other.
In this experiment, we will need a glass of water, oil, honey, and a candy. Drop one candy at a time and observe what happens to the candy when it enters the liquid. You'll notice right away that the candy behaves differently in each jar. Viscosity depends on the size and shape of the particles that make the liquid, as well as the attraction between the particles. Liquids that have a low viscosity flow quickly, just like water and oil. Liquids that have a high viscosity flow slowly, such as honey. Viscosity can also be thought of as a measure of how thick a liquid is. The more viscous or thick a liquid is, the longer it will take for an object to move through it. In our experiment, the candies took longer to sink when dropped into the glass filled with honey than they did when dropped into glass filled with water and oil. Therefore, we have shown that honey have a higher viscosity than water and oil.